In this question, we're going to talk about how to determine the minimum or maximum area um, given a wire under certain circumstances. So we have a wire of length 10 meters and it's divided into two parts. One part forms a right isosceles triangle and the other forms a rectangle with length twice as long as width. So basically what we're saying here is this wire is cut into two pieces. And what we're going to do with those two pieces, we're going to make a rectangle and an isosceles right triangle. I didn't draw the triangle too well, but just imagine both of these are the same length right there. And then with the rectangle, imagine that this shorter portion is 1/2 as long as the longer portion. Now, the perimeter of this triangle and the perimeter of that rectangle add to 10. Okay? All right, interesting enough. Now, we want to determine where to cut that wire so that the overall area is a minimum, and then also where would the overall area be a maximum. So we need to let x be something. You know, a lot of times we get down to a tough question, first principles, we say, well, the first thing we need to do is write a let statement. Let x be, and then the question is what? And so what one thing we might do is let x be the base and height of the isosceles right triangle. Since it's isosceles, we know those two are the same. We can let x be that length right there. Okay, now if we let x be that right there, then we know that the hypotenuse is going to be root 2 times x. Now, how do we know that? Well, simple. This hypotenuse that I'm tracing right there, we know h squared equals x squared plus x squared. So in other words, h squared equals 2x squared. That means h is the square root of 2x squared. So that's the same as root 2 root x squared. And you might say, well, the square root of x squared is the absolute value of x, but we know that x is non-negative. There's no way x is a negative value, so we can just call it root 2x. Okay? So now, having said that, we know the perimeter of that right isosceles triangle is x plus root 2x, which is the same as 2x plus root 2x, which is the same as x times 2 plus root 2. Now, this perimeter of this right triangle and this perimeter of this rectangle add up to 10. So rectangle's perimeter plus triangle's perimeter equals 10. That means the rectangle's perimeter is equal to 10 minus the triangle's perimeter. And so that's what we have here. The perimeter of the rectangle is that amount. Okay. Now, we also know that there's this width right here is half as long as the length. So we could say that the length is equal to 2w, okay? And so what we can say is the overall perimeter of that rectangle is w plus 2w plus w plus 2w, which is 6w. And since we know the perimeter is 10 minus the quantity of 2 plus root 2 times x, we can say 6w is equal to that, meaning w is equal to this amount right here, and 2w is equal to this amount right here. Okay, so what we're doing is, in terms of x, we have a value for the shorter side, which is 10 minus the quantity 2 plus root 2 times x all over 6. And then we also have a value with respect to x for the longer side of the rectangle, which is the same numerator but only divided by 3. Okay, now let's consider the domain. It's possible, think about this, we have a wire and it's 10 meters long. It's possible we used it all to build the rectangle, and that would mean the area of the triangle was 0. And if the area of the triangle was 0, that would mean that each of these x values was also 0. So it's possible that x could be as small as 0. We know x has to be greater than or equal to 0. On the other hand, it's possible that the entire thing was intended only to build the triangle and our rectangle is 0. So that would mean that the triangle had a perimeter of 10, because all 10 meters of the wire were used to build the triangle. If that was the case, then the perimeter of the triangle would equal 10. X would be 10 over 2 plus root 2. So we can rationalize this denominator by multiplying numerator and denominator by the conjugate of the denominator. Okay, and when we do that, we've got 10 over 2 plus root 2, multiplying top and bottom by 2 minus root 2 gives us 5 times 2 minus root 2 ultimately. Expanding that denominator the way we did here gives us this longer expression. And then the negative 2 root 2 and positive 2 root 2 cancel, and we just left with 4 minus 2, which is 2. The top has a factor of 10, the bottom has a factor of 2, so we can cross out the 10 and the 2, and we have a 5 up top. Okay, so we can see that the domain is going to equal anything between 0 and 5 times 2 minus root 2. Now, depending on your philosophy, you might say, well, we can't really say that x could equal 0, because if we did, then we'd be saying there's no triangle at all. And we can't really say x is equal to 5 times 2 minus root 2, because if we did, then we'd be saying there's no rectangle at all. And philosophically, I read that question so as to say that there is one of each. So depending on how you think of it, you might put equal signs in your domain, and you might not put equal signs in your domain. Okay. Now, we know that the overall area, that's the thing that we're trying to minimize or maximize. The overall area is equal to 1/2 base times height plus length times width. So the base and height of the triangle are both x. The length times width of the rectangle are given by this right here. And we might be given our option to round the answer. We'll do method 1 with rounding, method 2 without. If we're allowed to do a little bit of rounding, then this part here becomes 0.5x squared. This part here, we end up with 5.556 minus 3.795x plus 0.648x squared. Collecting up our like terms, because we have a couple like terms here and here, we get, and then by the way, 5 times 2 minus root 2 is roughly 2.929. So collecting up our like terms, we would get this expression right here. Determining the derivative and setting it equal to 0 would mean x is roughly 1.65. And then we could simply figure out what is the area when x is 0, what's the area when x is roughly 1.65, and what's the area overall when x is 2.929, because the 0 and the 2.929, if we're allowed to use rounding, the 0 and the 2.929 represent the endpoints of the domain. Well, we would say the minimum area occurs when x is roughly 1.65. Since the triangle is approximately 3.41x, because that's what 2 plus root 2 roughly equals, then the perimeter of the triangle would be roughly 5.63 to minimize the overall area, and the rest of it, 4.37, would be used for the rectangle. Okay? Now, and we would say the maximum area occurs when x is 0. If you go back here, we see when x is 0, we get the maximum area. Okay, so the wire's not cut at all. No triangles formed, but instead the entire 10 meters is used to create a rectangle. That gives us our maximum area. But now suppose we didn't want to use any rounding. We don't have to, of course. What we have here with the 1/2 times x is simply 1/2 x squared. Distributing our numerator here, we get this long expression. 3 times 6 is 18. And we can actually collect up some like terms, do a little bit of, there's a little bit of distribution work here and some collecting like terms, but we get this expression right here. Okay, and we can say that instead of putting it note that the terms in red are like terms, so we can add them together. One thing that we're doing here on the next line, what we did, we left it the same as it was on the previous slide, but then we turn this x squared over 2 to 9x squared over 18, so that we can have our common denominators. And then the slide is telling us these two red terms are like terms. And so what we really have is this expression for overall area. And we know that we can call this 15 plus 4 root 2 times x squared over 18 minus 20 times 2 root 2x over 18 plus 100 over 18. We're just taking that fraction and breaking it apart, changing the orders to put them into more of a standard trinomial ordering. Okay, so now the coefficient of x squared is 15 plus 4 root 2 over 18. The coefficient of x is 20 times 2 plus root 2 all over 18. That can be reduced to 10 times 2 plus root 2 over 9. And then 100 over 18 is 50 over 9. Now, setting the derivative equal to 0 means multiply 2 into that coefficient, like we did here, and making it just a term with x. And then the coefficient of x becomes a constant term when you do the power rule with the derivative. And then we can obviously reduce this fraction. Reduce the 2 and the 18 becomes a 1 and a 9. So we get this coefficient times x is equal to this expression right here. Multiplying both sides by 9 gives us this expression. And we can say, therefore, that x is equal to 10 times 2 plus root 2 over 15 plus 4 root 2. We can now, if we wanted to, rationalize our denominator. So multiplying top and bottom by the conjugate of the bottom gives us this long expression here, after, of course, we distribute. And so we get that long numerator over that denominator, and we end up with 10 times 22 plus 7 root 2 all over 193, which is roughly 1.65. And that fits within the domain that was given earlier. Now, if we let x equal 0, we get an overall area of 50 over 9. If we let x equal 10 times 22 plus 7 root 2 all over 193, then after a lot of work, we get a overall area of 2,605,500 minus 694,800 root 2 all over 670,482, which is roughly 2.42, consistent with the answer we had when we weren't doing any rounding. And then if we let the x value be 5 times 2 minus root 2, we ultimately get an answer of 675 minus 450 root 2 all over 9, which is roughly 4.29. And so we would say that the minimum area is the second case right here. And this is, again, consistent with what we did when we were allowed to use rounding. And the maximum area is the first case, which is consistent with what we got when we used method 1 using rounding. Okay. So if we weren't using any rounding, x was equal to 10 over, times 22 plus 7 root 2 over 193. We would know the perimeter of the triangle would be 10 times 58 plus 36 root 2 all over 193. And the perimeter of the rectangle would be 1,350 minus 360 root 2 over 193. And so to minimize the overall area, we'd cut the wire such that a certain amount was used for the triangle and the other amount for the rectangle. And we would notice the maximum area would occur when x was 0, and so all 10 meters would be used to build a rectangle, and there'd be no triangle at all.